right, there it is. All right, so 10.3. All right, so 10.3 is all about ellipses. Let me give you the general game plan for how the equations of ellipses go, how the equation of an ellipse. Oh, I'm sorry, I forgot to charge my little pen thing here. Sorry, back to it. Okay, so there we go. So equations of ellipses, they look like this. So an ellipse is like a long circle, right? It's either that way or it's that way. You know, either tall and thin, wide and short. And the equations are basically x squared over a squared plus y squared over b squared equals 1. So I'm giving you the general form of the equation of an ellipse. So, yeah. And what the a is, this would be like over a and back a. This would be up b and down b. Now, it's the same thing when you put them on the other axis. This is over a, back a, up b, down b. So really, this one equation can work for either one. Good so far? Is that making sense? How's this different than the parabola equations that we did last week, you know, and 10.2? What's different about like the x and the y, for example? Do you notice something right away?
Both squared.
Both squared, exactly. Everybody see what Tim's seeing? Both are squared. Both x and y are squared, right? Remember, what's the unique mark of the parabola? What we did last week. Just one letter is squared, and the other is not, right? One letter is squared, the other is not, right? That's why you only have one branch. Remember me saying the parabola's got one branch, whereas the ellipse is like two branches that get together. And I'll talk about tomorrow that we'll do a hyper. What we're going to do tomorrow, it's going to be exactly the same. You know, half of tomorrow we'll finish this up, but we'll begin, I hope, tomorrow around 20 minutes till. We'll begin the next section, which is our last one, which is hyperbolas. The only difference is the middle will be minus. It's exactly like this, except the middle will be minus. And what that'll do is that'll turn the branches away from each other. They'll be up, down, or right, left, away. But again, two branches because two squared letters. Whereas parabola only has one letter squared, the other not. So it's only got one branch. Okay. So now, so how do you know, like, which? Oh, here's the picture. Can you see it? Is it on? Yeah, it's on the screen. Okay. Here's the picture over here. So how can you tell? It's kind of small, huh? How far up and down? Like, what is this point? How far up and how far down are those two? Is it 4?
4 or 5.
1, 2, 3. It looks like 4. Yeah, it looks like up 4, down 4. Yeah, right 5, back 5. Huh? Everybody seeing that? So up 4, if you can see those little marks way over there, and right 5, left 5. It looks like where those edges are hitting, right? And so what does that mean then? Let me help you. You know, as far as the x squared, y squared stuff. A lot of as we go on today, tomorrow, the next day, and we look at these equations, there's going to be a lot of the a and the b. And they're going to be moving around the A, sometimes under the X, sometimes under the Y, you know, all that kind of stuff. Let me just say a rule right now, and then I'll just keep reiterating as we go through to make life a little easier with the A and the B. And Math Excel moves them all around and does some weird things. Here's the simple rule. Don't worry about A and B. Don't, because Math Excel will say, well, if it's wide, then the A is under the X. If it's thin, the A is under... I think that's really confusing. A and B are just letters, right? Call them Joe and Tom. They're just letters. Remember this. Whatever's under X, call it A, call it B, call it Joe, whatever. Whatever's under X has to do with right, left. Because the x-axis is right, left. Whatever's under Y, whatever you call it, is up, down. Because Y is up, down. Just think that way. Don't sweat the A and the B, and it'll be way easier to deal with these equations. So, Math Excel sets it up a little warning. If you do the question help, they get all specific, and I think that's just kind of confusing for students over the years. All right, so here we go. So when I look at this picture, how far is the right, left? The right, left edges are 5, right? 5 right, left 5. So that would be x squared over 5 squared. 25, in other words. Good so far. You got to square. The formula says square the edge, right? Plus, and how far is the up, down? Because up, down's under y, because y's up, down. 4, right? 4 squared equals 1. There's always an equals 1. Just like in the parabola formula, there was a 4 automatically there. In this formula and the one tomorrow, there's automatically a 1. We'll talk more about that as we go. So there it is. Which one of those is that? Oh, looks like, is it B? Yeah, right. They want you to, on a test, I don't care. I'm fine either way. But yeah, for Math Excel, there we go. And well, it's not multiple choice on the test, as you know. All right. So good. Questions on that one? This will be easier than the parabola. That's why I'm really encouraging you. Get through that 10.2. Come see me. Grab me after class upstairs. Because 10.2 is the hard one. 10.2 is the hard one. You know, this is easier. So, right. Okay. So here we go. So we got an equation. X squared over 36 plus y squared over 4 equals 1. All right. So they're going to ask me some specific questions. I don't think it's a problem. Let's just get a picture. Like I've said in all these, if you get the picture, all the questions are easy. You know, the picture worth 1,000 words is true. So, okay. So this is an ellipse. It's an egg shape, you know. So what do I do with that 36 that's under the x squared? Yeah, square root it, or you can just look at it and go, look, that's 6 squared, and the 4 is 2 squared. And yeah, same thing. Either way, just root it or just write it that way. It's good either way. So what does that mean then about the picture? Underneath x is 6 squared. So that means right 6, yeah. Boom. And left 6. Boom. Right? That's the right and the left edge because it's under x. Right? Remember, again, I don't care if it's called A or called B or whatever. It's under x, so it's right left. And then what's under y is 2 squared. So that means it's up 2, down 2. So my drawing is not the best. Looks like a little... Anyway, there we go. So good on that. Now, they're going to ask you a series of questions. They're going to say, what are the coordinates of the vertices? Vertices mean this point and this point. Yeah. Now, let me start talking about, this is called the major axis. Let me give you some more information. And this is the, you can put all this on your 3x5 card for the exam because I don't think it's important to memorize this. I don't think it's going to really affect your life to have these kind of things memorized. Major axis is the wider one. So if the thing is wider than it is tall, like this one, then the major axis is the bigger one. So when we do an ellipse that's tall like that, then the y will be the major and the x will be the minor. Does that make sense? The major just means the bigger. Which direction does it go bigger? So ours goes bigger right left, so that's called the major axis for him. And the minor is the up and down. And so what? Well, whenever they say what are the vertices, they mean the 2 edge points on the major axis. That's what they mean by the vertices, the major edge points. So let me write that for you. So the vertices are the edges on the major axis. Okay, and what are those? Well, it's this point and this point, so it's 6, 0, and minus 6. So they want the coordinates. Notice it says ordered pair on the question, right? Ordered pair. So they want, remember that always means they want parentheses, comma, the whole thing, right? 2 of them. So here's exactly the answer. Does that make sense so far? Are we good? You guys got that down? Can I flash away from that picture? Now, we're going to find the foci. So let me go. You guys got that copy down? Can I go to a fresh screen on that? Let's find the foci. All right, so how do we find, so part B, next part, find the foci. Let me draw our picture again. So again, it's right 6, left 6, up 2, down 2. Okay, so the foci. So foci is just plural for focus, right? The 2 focus points, in other words. So just like the parabola had a focus point inside of it, we talked about that for a searchlight or a satellite dish, that's where the receiver is, right? Focuses everything there. In the same way, an ellipse has a couple of focus points, plural is foci, and they're on the major axis. And I don't know where, let me give you the formula first, then I'll show them where they are. The formula for the foci is c squared is a squared minus b squared. It's almost like the Pythagorean theorem, right? But with a minus. And the c is the foci location, distance. It's the distance from the center to the foci. So c is the foci distance. Now that's different, hold on. That's different than the parabola equation. What letter did we use to represent how far to the focus point for the parabola last week? A. So I hope you're not getting confused. That's why I'm giving you the 3x5 card specifically, because all these little letters can be confusing, right? We used A last week for how far to the focus of the parabola. And now we're using C today and tomorrow for the last two sections for the focus. A and the B are what are under X and Y, right? Okay. So, all right, so here we go. It's just like the Pythagorean with a minus sign in the middle. So what's my A? Squared. Yeah, it's 6 squared. And what's the B squared? 2. So remember the 6, back 6, 2, down 2. That's that, right? And there would be no chance. Again, this is where I'm saying, don't worry about A and B. Is that X and Y? Look, if you're subtracting two things and this side is positive because it's squared, you got to put the bigger one first. You would never go 2 squared minus 6 squared because that would be negative. How could something squared equal something negative? That couldn't be. You see why I use... Don't sweat the A and the B. Just be reasonable about it. Say, hey, the bigger one's got to be first when you're subtracting two things. It's coming out positive. Okay, so yeah, so it's just it's real natural. I think it'll be easier for you to think that way. So C squared is 36 minus 4. C squared is 32. So C, what's C then? Yeah, the root of 32. I don't know if they want you to simplify that. Oh, it says type an exact answer. Yeah, let's try both. What is the simplification of root 32? I don't mean the decimal, but I mean the, remember how to break it down with the pairs and all that? Let me show that. Yeah, you remember all that? Right. So like 4 times 8, and 4 is 2, 8 is 2. Remember how to break down all that stuff? So then, so I broke down the 32 really into 5 2's multiplied. And then it's like I always tell my algebra students, a 2-for-1 deal, right? Basically 2 in, 1 out, 2 in, 1 out. So 2, whoops, I just erased them. So 2 2's in, 2 2's in, sends 1 out, right? So what comes out? 2 times 2, 4. What's left in? This extra 2. So C squared was 32, but C is 4 root 2. Sorry, I'm being kind of scribbly there. So C is 4 root 2. We good on that? Remember all that? So then what are the coordinates of those vertices? It is... over, now what is, somebody have that in a calculator, what is 4 root 2, or just what's the root of 32? It's going to be 5 points, so it's 5 something. 1, 2, 3, 4, so it's 5 something. I don't really care anymore. I got it good enough. It's 5 something, 5 something. So this is minus 4 root 2, 0, and right here is over 4 root 2, 0. See these two locations? 5 point something, huh? Yeah, so it's almost 6. So the foci points, remember I said they're on the major axis? The major axis, right? In others, they're not here and here, are they? They're not up and down. They're always on the widest axis. Everybody tracking with what I mean by all that? Right? The foci are always located on the major axis. And we got 4 root 2, so that means right and left, because our major axis is right and left. So right 4 root 2, left 4 root 2. Just like that. There's the foci. What the foci are, I don't always have a lot of time to because I'm so busy with the equations. Remember I told you, well, let me not review, let me just say, have you seen how, does anybody know already? How do you make up an ellipse? What do the foci have to do with the actual making of an ellipse? Do you know that? What it is if you took a nail on a board and you put in two nails on a board at the focus points, at the foci points, at these focus points. If you put a nail and you had like a loose string attached to them, make sense? And then you pulled that string till it was tight. So like, just pull it tight with it, and you put a pen here, or a pencil, and you drew, holding the string tight. See how that would kind of go if that string was tight, right? Get the idea? If you had 2 fixed nails with a string connecting them, and you pulled the string tight and drew as tight as you could, and then went down as well, you'd get an ellipse. That's what an ellipse is. It's the focus points generate the ellipse. Just like for the parabola, the focus and the directrix line generated the parabola. Now, I'm not showing all that detail. I'm not showing the derivation of where the formula comes from. But like always, open invitation. Come see me. Me and Roberto did it last week. He came with the tutor, our tutor. He came by and said, hey, I want to see how that parabola one drives. So we drive it. It was great fun. Come on by. I'll show you those details. But we don't have time to do that in class. We got too many equations to do. So anyway, that's what it is. That's what the focus points are. Let's see. Okay. So here we go. So same kind of thing. They're giving us an equation. They want us to figure out the information about the ellipse. But this one's got an issue. Do you notice? Something funny going on there. It's not in the right format, is it? Yeah, it's supposed to have one. Remember the general setup is x squared over something squared plus y squared over something squared equals 1. Yeah, you must have 1 on the right side for these ellipse things, right? Here we go again. Plastic surgery, removing the wrinkles, making it look different without being different. So much of math is that, isn't it? We have to give it a certain look so that we can do what we need to do, graphing or whatever. Just like for the parabola last week, we had to get that 4 on the right side. We had to make it have that look, right? So now we have to make it have a certain look because it's easier for us to graph when we do. So what am I going to do to make that have a 1 on the right side? How do I turn that 9 that's on the right side into a 1? Divide by 9, exactly. So let me rewrite this one up here. So 9x squared plus y squared is 9. Divide through by 9. So x squared plus y squared over 9 equals 1. Now it's in the right, well, almost the right. Let's put the right numbers underneath as well. So how could I'd like to put numbers underneath both those squared, right? That's the real look I'm supposed to have. So x squared alone is the same as x squared over what squared? 1 squared, right? See how we're just always doing plastic surgery? We're always making it look different without being different, right? In math. I mean, that's half of math, I think. What about the 9? 3 squared. No. That helps us graph, doesn't it? So now when it comes to graphing, we can do our little axis system. So is this one going to be wider or taller? Yeah, because what's underneath y is bigger, huh? What's underneath y is 3 squared. So that's up 3, down 3, and then what's underneath 1 is 1, so just right 1, left 1, huh? And there we go like that. Is that good? Is that making sense how we graph those? That's why we give it that look, then it's easy to graph. So now, what do we need to do from here? Now, they're going to ask us all the same questions. Can you find the foci points? Let me give you a second to do that. Well, first off, are the foci points going to be up, down, or right, left? Up, down, because the major axis is up, down, right? Foci are always on the major. Yeah. So anyway, go ahead and see if you can find the foci. Remember the equation? What's the equation for foci? Yeah. Miss Jones, they really don't usually answer like it. It's usually silent when I ask questions, but they're pressing you today. Thank you. All right, yeah, so it's diagram here with a minus. Diagram here with a minus, right. Okay, find the C there. Yeah, do you see how technically I've got the formula backwards for this setup? But this is where I'm saying, don't worry about all that. That just gets confusing. In other words, technically, picky technically, I've actually got it backwards. Because if you really said, well, look, Ms. Tarrant, you said A is underneath X, so then this is A, so that's 1 squared is the A, and the B is under Y, so that's 3 squared, and that's going to be negative. Right, true, guilty, I agree. But in the end, I think it's rather, so this is where math excel. And I understand, they're just trying to be really careful. They go, oh, no, okay, now you got to call that B squared and this A squared because technically the Y is bigger and they put the A under the bigger one. Yeah, they're right. But I tried teaching it that way a long time ago, and students were completely confused. So instead, I'm saying, yeah, that's true, but don't worry about all that. Just put the bigger one first. It's got to be the bigger one first, right? And who's the bigger one? 3 squared. It's got to be. But they're technically right. If you do the help button, they'll go through all that. But I don't want you to be confused by that. So 9 minus 1, so C squared is 8. So C then is the root of 8. And what is the root of 8? Yeah, you good at breaking all that down? So the root of 8, kind of running out of room. You see that up there? I'm going to break that down there. It's 2, 2, 2, right? 2 times 2 is 4 times 2 is 8. 2 for 1 deal, roots are. 2 2's in, 2 comes out, 2 root 2. So, now, where is that, though? It's up, down, 2 root 2, right? So it's like up here and down there. Everybody with me? So it's over 0, up 2 root 2, and over 0, down 2 root 2.
So there's over gonna be at 0?
Well, we're going to start moving them. Yeah, for now. Pretty soon we're going to start moving the whole things around. But it's always from the center. How about that? It's always directly from the center, wherever the center is. Straight up, straight down, or straight right, straight left. From the center, which is at the origin for now. Yeah, good question. Is that good? Does that make sense on finding those focus points? Questions I can answer? Other questions? Okay. So how we do one of those. So, okay. So let me let you do the first couple steps. Go ahead and can you see that? X squared plus y squared is 81. Do the first couple of steps on that one to make that thing have the right look. Roberto, I was telling them about how we were deriving the parabola equation.
Oh, yeah.
And it was fun, right?
Yeah, it's good.
And it was quick. What was it? 5 minutes?
Probably.
10 at most? All right, what do we have to do to give this the right look? Oh, no, remember what's the right look? What's got to be on the right side? 1. It's all about making that a 1 on the right side by dividing. So just divide through by 81. That's an 8. Does that make sense? So whatever number is on the right side, you just divide through by that number. Right? So make a 1 on the right side by dividing. Yeah, whatever is on that right side, you just divide through by that number. So then we get x squared over 81 plus y squared over 81 equals 1. That's almost the right look. Now I'd like to write that as something squared, something squared. So yeah, it's clearly 9 squared, 9 squared. So I'm going to stop there. You know, I don't want to go on and mess around anymore. But you just tell me this. What kind of ellipse is that going to be? It's going to be a circle, yeah. It's same width, and it's up, right 9, left 9, up 9, down 9. We call that kind of an ellipse a circle. In other words, a circle is a perfect ellipse. Ellipse is the more general category, and circle is the perfect kind. Like dog is the general category, and I don't know what, German Shepherd is the perfect kind, or whatever your favorite kind. You know, all right? So you get the idea? So there's ellipse. Circle is a kind of ellipse. It's a perfect ellipse, right? Just like a square is a perfect rectangle. Same kind of thing, right? All right, and you could do the rest. Foci, Tim.
So would the foci for that be 0?
No, the foci would be, it would be 0. You're totally right. Yeah, because the c squared is a squared minus b squared, yeah, which is going to be 9 squared minus 9 squared. I'm like, no. Yes. C squared is 0. C is 0. Yeah. So the focus comes right to the middle. Oh, of course, because how do you make a circle? Yeah, I like that. Good observation. Because how do you make a circle? You put one nail down and you draw with the string, huh? So the two foci have come together into one. That's what's happened when an ellipse turns into a circle. Yeah, good observation. I like to see the physical connect with the equations. You know, those relationships. Yeah, good observation. Yeah. So the foci would be 0. All right, let's keep. Okay, so here we go. They want us to go backwards to the graph, so let's do it. The center is at 0, 0. In a little bit, they're going to move the centers, like Seth was talking about. And then, okay, so the focus point. Go ahead and put the focus point and the vertex on the graph. Well, I guess I just did too. Are we good there? They're on the y-axis, aren't they? Over 0, down 15 to the focus, down. Oh, by the way, the focus points are always inside, aren't they? They're always inside the ellipse, just like for the parabola, inside the branch. Okay. So let me ask you, are we good to there? Let me ask you this question. Is this ellipse taller or wider? Taller. We know because the focus is always on the major axis, and so is the vertex, right? Both on the major axis. The major axis must be up, down, which is the bigger one. So it must be like this. Well, something like that, huh? Taller than it is wide. And this must be up at 17. There must be another focus up at 15. They're always symmetrical from the center. The center is at 0, 0. Good so far? Got to be. Another focus, another vertex. Okay. Can you write the equation for that? Let me give you a second. You know, in general, it's good just to write down as x squared over something squared plus y squared over something squared equals 1, right? So do we know either of these somethings right now? Which one do we know?
We know B is 17.
Yeah, whether you call it A or call it B or whatever you call it, we know the up-down is 17. So that's up-down, so which letters does it go under, X or Y? Up-down, Y. It's got to be 7, that's a 7 there. 17 squared, doesn't it? It's got to be 17 squared. Okay. Now, how do we find out, like, how we don't know how far the right left is?
The formula, right?
Yeah, what formula?
I forget the name of it.
Yeah, the c squared is a squared minus b squared. Exactly. That's where we need to go, right? The focus formula, which is really the Pythagorean of the lights, right? Yeah, so we get to use that. Now, let's be a little careful in using that. What is the c in that little focus equation? What is the c? Yeah, that's the focus distance, right? Yeah, that's the 15. Everybody good so far? The c is the focus distance. The a and the b are what's under x, y. Now, here's where you need to be a little careful. You need to be a little careful with a and b. But again, I wouldn't do it the way the Math Excel says, with, you know, real technical. I would just kind of be reasonable for a minute. I've got the y right now. Is the y the bigger one or the smaller one?
Bigger.
Yes, it's taller than it is y. Right? The y is the bigger one. Right? So the y technically is here. The front, not the back. How do I know? So technically on this one, the y is the a. That's what Math Excel says. Oh, the y is big because, you know, whatever. Why do I know? Why do I know the 17? This will mess you up if you put the 17 in the back, you get the wrong answer. How do I know the 17 is technically the a goes in the front? Because when you subtract two things and it's coming out positive, 15 squared positive, right? How do you subtract two things to get a positive answer? The bigger one has to go in the front, right? When you subtract two things, if you want a positive answer, the bigger one has to go in the front. So, and I know the 17 is the bigger one because it's more up down than it is sideways. Everybody getting that? That's a tricky little point, which confuses a lot of people. Can I answer questions on that? Does that make sense? Let me just say, 17 squared in front because it's taller. And so when you subtract, bigger in the front, right? Whenever, is that on the screen? Yeah. So when you subtract, the bigger one is in the front. It's got to be. So yeah, so technically that's the A, whatever. So let's work that out. 15 squared, 225. What's 17 squared?
289.
Thank you. 289 minus b squared. So subtract the 289 from both sides. And that's some number 64. Minus 64 is minus b squared. So b squared is 64. So b is 8, huh? So this is 8 squared, and we're done. Does that make sense how we did that? The trick was using the focus equation. And, you know, with subtraction, the order does matter, huh? You've got to make sure you're putting the bigger one first. And the bigger one, you can look at the picture and tell the bigger one's the up, down, is the y. All right. Okay. Try that one. I encourage you, draw a picture. I have a minute left, and I got to stop. So let's do this one rapidly. So the center's at 0, 0. The vertex is over 0, up 7, huh? And so that means the other vertex is down 7. These are vertices, which means it's more up, down than it is right, left. I didn't draw that too well, but it's supposed to hit like this. Anyway, right, you get the idea there. It's more, right, so we know the major axis, I did it again, is the up-down. We know the major axis is the up-down. So what does that mean? Okay, so we got x squared plus y squared is 1. So the up-down is 7 squared, right? Are we good there? Now, look at this b. They're going b is 3. Now, I know, you know, again, I'm trying to make it as simple as possible. Don't worry like ax, by. Just think this way. I already know what goes underneath y, so that 3 must be what's underneath x. It's the only one left. 3 squared. And there we go. Is that good? Without worrying so much about ax, by, and all that. It's the only other one. All right. I'm going to have to stop and give the floor to Miss Jones here.